Hey guys, from the Tiny Lab Build site. As you can see, we have the shroud over the sheathing. So we had the walls framed up, then we put the sheathing on, which is the plywood. That's very structural, it's structurally important. And then over that plywood, because of course plywood is not a good barrier for things like water, we have the shroud. The shroud blocks water out. It also blocks air leakage, which is incredibly important. It is the most important thing for most homes to make them better. So ours is already very airtight because of the shroud that we can see on it already, that's taped at all the seams. And we have the, on the front, the shed built, which my mother calls the mechanical closet, which I actually think is a way better word for it. So this is the built out triangular section that you can see there. Now I modeled this. We kind of saw behind the scenes of how a build works in the conventional sense, because I was the architect and I said, wouldn't it be cool to have a peaked front where it comes to a point and then it also slopes down from the roof level of the house so that it meets at this really cool geometric thing? Great, that's all good. What generally an architect would do in that case is, that's weird, just field measure it. Field verification is what they call that. Now what happens next is they hand it off to a builder, and the builder says, well, that's weird, I'll come up with a framing plan for that. And their job really is to get the thing done as fast as possible for the lowest possible budget. That's what most people want. So at that point, the whole thing starts falling apart, because this thing really requires 2x4s that are cut not just on one angle like this, but on 2 angles. So I had to change the angle of the saw that we were using to not just cut across like this, but also down the face of it. Ridiculously time-consuming and nerve-wracking. As you can see, I made little templates that say, this is the angle that you use on the tilt, and this is the angle you use on the turn. And we had to do that for every single one. The roof, the headers of the walls that hold up the roof are also tilted like that. Totally bizarre. The whole thing would be very weird to have in a conventional building situation, because nobody would take the time to really do all that stuff. So this happens to be fitting together very well. We're very happy with it. As you can see, it has the plywood on the roof. We haven't closed it in yet because, as you can see in that, we have the water heater, but we don't have anything else. We're going to put propane tanks. We're going to have the solar panels stored in there when we're not using them. And so all that stuff is really important. It also is very likely, since we're going to have all that in there, that we are going to scratch the very beautiful shroud that's in charge of blocking everything out of the house, out of the wall section. So we have this plastic stuff that we put up in there. This was very cheap. It's like corrugated. It's kind of like cardboard, but it's made out of plastic. And it's affixed to the house. We made sure to attach butyl tape. Butyl tape is this really sticky tape that will self-seal around nails, where we were going to nail it. And then we used these nails that have this giant head on it. It's basically a washer, to make sure that the nail doesn't punch right through the plastic. So these are on there to make sure that the white doesn't fall off. The white is only important in that it protects the black stuff from being scratched or gouged or poked at. So that's the way that that was put together. We are next going to show you what's going on inside the house. So if you want to keep on getting these updates and seeing the progress of this, please do subscribe to the channel and you can be kept automatically up to date. Like our Facebook page if you would for the tour, which is called Proof is Possible. You can find out more about all of that at proofispossible.com. Thanks very much for watching. Tune in next time.